Hi, today we would like to present our knowledge-based system project. The title is Motorcycle Engine Diagnosis System. I'm Kishore Analaki Kanun. Table of content consists of introduction, problem background and objectives, data collection and facts, methodology, chaining diagram, result and discussion, conclusion. Introduction. The motorcycle engine diagnosis system assists motorcycle owners in diagnosing common engine issues efficiently. It supports two engine types, two-stroke engines. These are often used in lightweight motorcycle, light scooters, and dirt bikes. Common issues include excessive smoke or overheating due to oil-fuel mixture combustion. Four-stroke engines preferred for fuel efficiency and reliability in commuter and touring bikes. Typical problems include oil leaks and starting difficulties. Timely and accurate diagnosis of engine issues is critical to prevent costly repairs and maintaining optimal motorcycle performance. Problem background. Challenges faced by motorcycle owners. One, lack of technical knowledge or diagnostic tools to identify engine problems. Two, common issues such as starting failures, overheating, and excessive smoke. Three, escalation of minor problems into costly repairs due to delayed diagnosis. Objective 1. To provide a user-friendly interface which simplifies the process of diagnosing motorcycle engine problems. To ensure accurate diagnostics. Leverages a rule-based system to generate precise diagnosis results. 3. Reduce time and cost. Minimizes the effort and expense associated with identifying and resolving engine issues. 4. Deliver actionable recommendation. Offers practical solutions based on severity levels for efficient problems resolution.
Assalamualaikum. My name is Nabil. I will present about the data collection and facts. Okay, first, our data source is from user customer is name and contact details. For engine type, two stroke or four stroke. For the symptoms, starting problems, overheating, excessive, and etc. For the facts, we store severity levels. Fact analysis using rules-based system that's with severity levels. First is low, minor issues, not immediate action required. Mid, moderate issues, workshop visit advice. High, critical issues, immediate attention required. Okay, next. For our methodology, we use backward chaining method. The system use predefines rules to infer conclusions based on user inputs. Next. Okay, for the methodology, step involved is first input collection. User provide personal details, rule-based analysis. The system applies diagnostic rules to analyze symptoms and determine the root cause. Severity assessment, assign severity levels low, mid, high based on the diagnosis. Report generation outputs a comprehensive report with diagnosis, severity, and actionable recommendation. Next. Okay, this is our chaining diagram. Full chaining diagram. Next. Okay, for the first part, this is when user start the system, that after diagnostic finish, it will generate the report and end the system. Same engine problems that diagnosis part. We have three question. Does the engine start? Check all leaks, check excessive smoke, and the logics. Okay. Next. Here, user must choose whether his engine is two-stroke or four-stroke, and he will proceed the logic. Okay. Next.
Okay, my name is Limiji. So, for the motorcycle engine diagnosis system, the result and decision is the system was tested was tested with various scenarios, including engine failure, overheating, and fuel shortage. The result demonstrates the system's capability to accurately identify common engine issues based on user input, assign appropriate severity levels to detect the problems, and provide clear and actionable recommendations for users. Discussion revealed that the system could be further enhanced by integrating more advanced features such as real-time sensor input from the motorcycle to identify the engine temperature. Next. For the conclusion, the motorcycle engine diagnostic system provides a reliable, user-friendly platform for identifying and resolving engine issues efficiently. So for our achievement, we got our accurate diagnosis, effectively identify common and specified engine problems, actionable recommendation, offer practical advice for maintenance and repair based on severity levels and times and cost efficiency. It will save user from unnecessary expenses by diagnosing issues early. So for future improvement, we could include IoT devices for real-time diagnostics and expanded rule sets to cover a wide range of engine problems. So for the next part is we'll go to the demonstration.
Okay, my name is Scott Wing Chun. Now I will talk about the code for the system. And the first part, we define the template for the flag we will use in the system. After that, we include two functions that will for the user input, which is the first input is the welcome the customer, and then the what his name is, the user can input the username. And then the second function is asking the user to input what type of engine. The first type is the two-stroke, and then the second type is the four-stroke. And then now is the rule for the system. The first rule is the get user input, yes or no. And then this input is like it will like continue to loop if the user enter the wrong input. And then the first rule is check if the engine start or not. And then the second rule is check if the fuel is in the tank or not. And then the third rule is check if the smart plug is working or not. And then fourth rule is checking the overheating. If it input in the Celsius, not yes or no. And then the fifth rule is check for oiling. And then sixth rule is check for excessive smoke in exhaust. And then the seventh rule is check for the clogged exhaust in the two-stroke engine. The eighth rule is for checking the exhaust port of the two-stroke engine. And then the ninth rule is check for the valve current in the four-stroke engine. And then last but not least, the last rule is for check for the low oil pressure in the four-stroke engine. And then last part of the function is generate a diagnostic report after getting all the user input. It will generate a report detail which part of the motor have the problem the user need to change or something. And then this is our main function. And then now I will demo the code. So in the system, it will ask the name of the customer, and then the second it will ask the customer to choose the engine type of their motor, and then it will ask the user about the engine start or not, and then the temperature, and then notice oil leak or not. And then after that, it will ask the exit move from the exhaust. After that, it will ask the exhaust corroded or not. And then is that oil coming from the exhaust port? After that, it will diagnose. If after all that, it will generate a diagnosis report for the user. So it will list the recommendation action to the user and then the severity of the level of that issue. So that's all for our system. Thank you.